A group of astrophysicists led by a specialist from Australia has discovered a source of repetitive radio signals in our galaxy for which there is no confident scientific explanation yet. The signal, lasting about 5 minutes, comes to us from a distance of 15,000 light-years every 22 minutes for at least 33 years. This is a very, very slow signal, which takes the discovery beyond the physics we know. This remarkable object challenges our understanding of neutron stars and magnetars, which are among the most exotic and extreme objects in the universe, said team leader, astrophysicist Natasha Hurley-Walker of Curtin University's International Centre for Radio Astronomy Research ICRA in Australia. Last year, astronomers found a similar long-period radio object in the observation archives, which received the designation GLEAM XJ160-20759, 5-523504. 3. It emitted a radio signal every 18 minutes, but since 2018 it has disappeared from the air. The Hurley-Walker team tried to detect something similar with direct observations and found what they were looking for: the object GPM J183910 with a radio signal period of 22 minutes. Moreover, the study of the archives showed that the source has been recorded since 1988, but no one paid attention to it, considering this to be impossible in principle. The fact is that such long-period radiations lie below the so-called Valley of Death for magnetars. For the occurrence of powerful radio emission, the magnetic field strength must be above a certain threshold, which depends on the speed of rotation of the magnetar. The slower the magnetar, one of the varieties of neutron stars, rotates, the less often a radio signal occurs. But too slow rotation of the magnetar is simply unable to create a magnetic field strength sufficient for the appearance of a radio burst. The object we detected is rotating too slowly to generate radio waves. It is below the death line, Hurley-Walker explained. Thus, two prospects emerged before scientists: either to change the physics of the occurrence of radio bursts of magnetars, or to assume that this is signaling a star of some other unidentified type. For example, these can be white dwarf-type stars in a magnetized and isolated state. In any case, the discovery of new long-term sources of radio signals hints that this happens in the universe more often and more densely than we imagined.